Right, here we go. Okay, I'd like to welcome everyone to the November Speakers Night. Tonight we have a talk by Chris Vaughan, who will be giving us pointers on enjoying our hobby when the moon is out and overpowering all the faint fuzzies that we love. For those of you who don't know Chris, I won't fully introduce him because that's Swapna's job. But he operates the David Dunlap Observatory in Richmond Hill, which is Canada's largest telescope. If you haven't toured the DDO, if you haven't gone up to Richmond Hill, it's not that far, and you really should make the effort. It is really quite something. And your alternative is to watch the Umbrella Academy on Netflix, where they have shot many scenes, and including Chris Vaughan, but he hides. I don't know why.
That's right. That's right.
Yeah. So after Chris's talk, we'll have a Q&A session, possibly a bio break, if depending on timing. And
no, off. Jesus.
Francis, if you could mute for me, unless that was a question. But I guess for now, if I'd ask our club secretary, Swapna, to introduce our speaker.
Yeah. Welcome, everybody, back to Zoom. Just for today and for our next meeting, out of an abundance of caution.
Do you not have your...
So would like to introduce Chris Vaughan. Thank you so much for joining. Chris is no stranger to the RASC. He's been in our meetings before, and you know, he is a very active member of RASC. It's my honor to introduce him as our speaker for November. So Chris will discuss his experiences while observing the moon for fun, for outreach, and for completing the RASC lunar observing programs. For those who are new, I think this is a really cool topic to cover. I know a lot of the newcomers have asked about the different certificates, so this is going to be a great introduction to the lunar observing program. He'll share observing tips and target suggestions and highlight some of the best books, apps, and web tools for exploring the moon from your driveway. Chris Vaughan is an award-winning astronomer and earth scientist with a lifelong passion for visual astronomy. He operates the DDO 1.88 telescope, volunteers for the RASC, hosts the Insider's Guide to the Galaxy show on YouTube, and visits schools and groups with his portable digital Star Lab planetarium. So if you're checking out his sessions are recorded on YouTube, so feel free, and I encourage you to check out the Insider Guide to Galaxy. Those are really cool sessions. Also, Chris's weekly astronomy skylights blog at www.astrogeo.ca is enjoyed by readers worldwide, and he is a regular contributor to the Sky News magazine, space.com, and several popular astronomy apps. In summer 2021, he co-authored the book, 100 Things to See with the Telescope. So welcome, Chris. Thank you, and it's our honor that you're here with us today.
My pleasure. Thanks for having me. Boy, it all adds up when you, after a while, doesn't it? That's amazing. Yeah, thank you so much. So yeah, let's share my screen and we'll get started here. Let's see if this works out well. Here we go. Cool. So I'm gonna share some of my experiences in making lunar lemonade. So you know, a lot of times during the pandemic, we were stuck at home under lockdown and needed things we could view from the driveway. Another thing that happens a lot of times is I'll get asked to do a star party for a school or something like that, and the only date available is on the full moon. So you know, you learn to find out what's cool to look at on the moon, and you can share that with the public. So what I'm going to talk about today is some full moon fun and features to look at on it. I'll cover, as Swapna said, some of my favorite recommended moon books, software and apps, and then give you a little bit of you know, what I've been up to in terms of moongazing with RASC's programs, and then end up with some of the favorite features I've seen along the way and some challenges yet to master. And obviously, to look at the moon, you don't have to have a telescope. It certainly helps, but
I have a feeling that perhaps,
hopefully you'll come away with some things to check out just with your unaided eyes or your, hello? Am I going through okay?
your at least for me, your audio dropped out there for a minute, but you're back.
Oh, all right. That's good. Thank you. So the what I'm going to use is this image by Michael Watson as a sort of a basis image for a lot of the talk. I'm going to use it to point out features on the full moon. And I've also got a visibility or observability guide icons here on the right that you'll see pop up: naked eye, binoculars, and telescopes. So obviously everybody's familiar with this sort of simple maps that highlight the major features on the moon. This one's got the lunar mare, color-coded in yellow. We've got the craters and the ray systems in blue, and then the Apollo landing sites are the red numerals. And when you're looking at the full moon up in the sky, of course, one thing you want to point out to people and note for yourself is that the mare are not all created equal. Some of them have more of a definitive round shape to them. Others are more odd shape. And then there are even different tonal differences in both their darkness and their colors. So you might notice that Mare Tranquillitatis is a darker bluer color because the basalts were enriched in titanium. That's one of the reasons why Apollo 11 was sent to Mare Tranquillitatis. They're also going to notice the ray systems on the moon, those streaks of brightness that are distributed around impact craters, generally the more recent impact craters. And this graphic is meant to just sort of give you the sort of the basics of what's going on. You've got your white light-colored anorthosite lunar crust. And then if you get a basin excavated in that crust, it gets infilled at some point in the lunar history with a darker colored iron-rich basalt. And then if something were to come in and impact into the anorthosite crust, it can actually blast some of that brighter rock overlaying onto the darker rock and give you the white streaks over the darker rock. In addition to that, you can also have a feature where an impactor comes in the lunar mare, and then the darker rock that's excavated from that impact can that get spread around that crater or even distributed on top of the adjacent white lunar highlands or even some of the adjacent ejecta from a previous impact. So there's all of these neat scenarios that you can create on the full moon in terms of the ray systems. So this is sort of just an explanation of what they are when you're seeing them. So ray systems are all over the place. You don't need a telescope to see them. You can look up with your unaided eyes, or you can grab your binoculars and find them everywhere. Almost uncountable how many ray systems there are. Obviously, the big ones that a lot of us talk about are the ones around the crater Tycho, which are actually asymmetrical. Not sure if you realize that there's actually a set of rays missing on the western half, lunar western side of Tycho. They're preferentially distributed to the east, so that any asymmetry in the distribution of the rays gives us a clue as to what direction the impactor arrived from when it created that crater. So Tycho is relatively young, about 100 million years old. That's actually been measured by the Tycho ejecta samples that have been brought back by the Apollo during the Apollo missions. Then we've got Anaxagoras up in the northern pole of the moon. Again, these are symmetrical rays, about 900 kilometers long, again, a few 100 million years old. Then we get into the Oceanus Procellarum region where we've got Kepler and Copernicus. The ray systems around these two craters are markedly different. They're sort of, rather than the linear, bright, straight lines of Tycho, we get these sort of almost raggedy or straggly ray systems around Kepler, which are about 300 kilometers in extent, and Copernicus, which are about 800 in extent. So it's already giving you the ability to understand some of the lunar geology just by looking with your unaided eyes at the moon. Here's one that's crossing Serenitatis that we're not quite sure if it's a Menelaus ray or if it's maybe something that's come from the north. Some of these mysteries remain to be solved by future humans exploring the moon, on its surface. So looking at a couple of these up close, so one of the favorite ones to see on a full moon, or when the moon is quite fully illuminated, is the asymmetrical ray system around the crater Proclus, which is near the border of Mare Crisium. And again, this has got a missing section to the rays, which suggested that the impactor came in at a very low angle from the southwest. So that's a terrific one to share with the public if you're doing outreach when the moon is bright and full. Another neat one is the rays around the dual crater Messier and Mare Fecunditatis. And that one consists of these two dominant streaks that extend to the lunar west that are about 120 kilometers long. They're consistent with an impactor that came in at about a 4-degree angle above horizontal from the east at about 1.7 kilometers per second. So this is a view of the rays around the full moon illumination, and this would be the same pair of craters during an obliquely illuminated time of the month. So the rays are not nearly as prominent when the moon is not fully illuminated. So another great feature of the full moon is how much brighter these ray systems look. Here's an example of some dark rays. So this is the little crater Dionysus, which is here near the Apollo 11 landing site near the edge of Mare Tranquillitatis. And this is an example where you've got the underlying Mare material having been ejected and spread in a halo around the crater Dionysus. So you've got the dark rays instead of the bright rays. Now, how about dark halo craters? Another example of that situation. So you've got the ejecta blanket that was spread out by the creation of Copernicus, and then subsequent smaller impacts into the area around Copernicus created these little dark haloed craters with lighter centers and dark rings around. So there's actually quite a few of them around Copernicus if you know to look for them. And they don't need you don't need a large telescope to see them. Any generally good optics will work. So we think that these are about 100 million years old. Some of these little dark halo impacts. Credit to Damien Peach for this nice photo. And another film one I always look at when the moon is full is the dark ash deposits on Alphonsus. You can see it's almost right smack in the middle of the lunar disk, just below the equator here. And I like to consider this sort of under the chin of Wilma Flintstone. If this is her eye and her bun on the top of her forehead and her hair, and her smile is here, her chin, and there's Alphonsus sort of just tucked under her chin. And these are the three, maybe four, you could argue, dark ash deposits that are remnants of prior lunar volcanism that are very, very evident when the moon is full. So this is another example of a full moon view of it, and then a moon under more solar, more of an angled illumination. You can see this photo by Gary Saronic really captures those dark stains and some of the pits that would have been the sources of the vented material that have come out and landed and spread out around the moon. Another set of those is up here near the northern section of the moon, north of Serenitatis, the crater Atlas. And here are two very dominant ones, very prominent ones in the crater Atlas. Then you've got the crater Hercules just to its west and the really bright Hercules G interior to that. So this is an easy object to see when the moon is full. So in terms of the full moon, if you're again with folks when the moon is full and you're showing them some of these features, a few of the other things that you can talk about are the ray systems, of course, the libration effects as the moon wobbles and nods, and the varying positions of the features like Mare Crisium and Grimaldi on the far side at different phases of the lunar's or times of the moon's orbit. Ask people what pictures or shapes they think the Mare make. One trick is to have them bend over and look at the moon upside down. Of course, the Maori people in New Zealand, they have a whole story about the shapes they see it formed by the lunar Mare, and they're all based upon the fact that they're viewing the moon inverted from what we're used to seeing. It's kind of a neat story if you want to look it up. And you can always teach everybody that they can cover the moon with their pinky fingertip. Even if the moon is giant, a super moon and full, it still works even if youngsters can cover the moon with their pinky finger because it's actually only half a degree across in the sky. And everybody can take a picture of the moon through their phone when it's big and bright. So that's another great thing to engage people with. Have a souvenir of the event. If you are finding the full moon is too bright, I mean, I have a big telescope, big 12-inch aperture telescope. The moon is really bright in that telescope. So the way to go there is to get yourself a moon filter or a neutral density filter, just to dial down the brightness and be able to, enjoy some time at the eyepiece for longer. All right, some of my favorite books that I use, and these are going to be things that I would refer to when I'm doing some of the observing programs. One of the gold standard books is Antonin Ruckel's Atlas of the Moon. It consists of 76 hand-drawn charts with a north up, so they're north up, which is a binocular style orientation of the moon. He's also got a set of 8 charts he's drawn around the rim of the moon, so the libration zones. And you'll note that the Ruckel chart numbers, so the 1 to 76, are often referenced in the material in support of the RASC lunar observing programs. It's not really in print, but I didn't have too much trouble finding used copy of it, and I do see it come up on AstroBiocell and places like that from time to time. So it's worth getting a hold of if you can. Now, one of the things is that this book tends to be a hardcover book, so it's not spiral bound. It's not necessarily easy to sort of manage at the eyepiece, but it is something that I have at hand. I even have a digital copy or a PDF version of this that I can bring up on a tablet, which makes things a little easier sometimes. There's just an example of one of the layouts. So this is this sinus iridium region. So you can see it's hand painted and then labeled features on the moon. And then with each of the major features, he's got whom it's named after and a little bit of information about the feature itself. Now, another fantastic find that I came across a number of years ago is the Lunar Field Atlas produced by Fred Days in 2011. And he actually produced this himself, and he generated it in 4 different versions. So the erect image for binoculars, the mirror image for telescopes with star diagonals like SCTs and refractors with star diagonals, inverted mirror image, and then inverted, and then just regular inverted. So these would be for your Newtonian telescopes. And it's got, he hand stitched together mosaic from the Consolidated Lunar Atlas into 38 charts, more than 2,000 objects labeled and indexed. And again, it's similar to the Ruckel Atlas, but what's neat about this one is that it's a download, it's a PDF. So you could print it out, or you could even just have it again on a tablet. Now, Fred's website where this used to be hosted has been taken down. I guess he's retired or moved on. But the Wayback Machine of the web actually will let you reopen it and access those files here with the link that I've got shown. I just wanted to maybe pause for a second here and mention something about something related to this that I've been thinking about recently. If you're someone that's been doing astronomy for a while and you've created tools or databases or archives, and those are maybe online or in written form, and you're thinking about retiring or taking their website down, maybe consider seeing if you can find someone to adopt your baby and keep that going, keep that legacy alive, even if you're not really interested in maintaining it yourself. When I was doing our insider's guide the other day about the Herschel objects, there was a list produced by Father Lucien Kemble of the Herschel objects that was digital, but it seems to have been lost in the ensuing few decades. So think about that. If you've got something that you've been doing and producing and building, don't let it die and fade away. Maybe see if you could get an astronomy club or a younger rascal who would be willing to take it on and keep it alive. So here's an example of that page layout for Fred Days' Lunar Field Atlas, and this is the same sinus iridium area, except this was the Newtonian telescope format, so it's flipped over by 180 degrees. So there's the Bay of Rainbows down there in the corner. Similar idea. he didn't draw the moon. In this case, these are photographs, but he did label everything and give you the facts and figures about it. Another great book to have with the telescope. This one's really neat because it's actually full of fantastic high resolution photographs of pieces of the moon or features on the moon. It's generated by Alan Chu, Wolfgang Petsch, Mario Wygand, and Storm Dunlop, called the Cambridge Photographic Moon Atlas from 2012. It's still available to buy in Kindle form, so it would be digital on your device. I have a hard copy that I bought a number of years ago, but that may be out of print, but you could look around and see if anybody's got used copies or books or something like that. What's great is that the photos of the objects tend to be collected for different lunar illuminations or different phases of the lunar month. So that's neat to be able to see a feature at different times of the lunar month. It does have really nice descriptions about the objects, but I did find some errors when I was reading through it. So you might want to put some post-it notes in it as you go to remark on those. So here's an example of the layout for Tycho, and here you can see the crater Tycho photographed at a number of different lunar illuminations, which is fun. Now, if it's cloudy or if you just want to do some research about the moon and get ready, this is another gold standard book that I read this one once cover to cover, and I'm ready to start it again as soon as I finish some other things I'm working on. It's The Modern Moon, A Personal View by Charles A. Wood from 2003. What's great about it is it's a terrific mix of discussion about the lunar geology, but he also does descriptions, feature by feature descriptions of sections of the moon. So say, the concentric wrinkle ridges in a lunar mare, things like that. He does, and there's information about the history of lunar exploration, both telescopic and some of the, on the ground, boots on the ground exploration. Very readable. Again, it seems to be out of print, but you can find people selling used copies of it here and there. One of my neat favorite things that I've discovered when I was reading this book is Bill Hartman, who's a famous lunar researcher. He did a technique called the hemisphere projection technique. So what he did was he took photographs of the moon, high resolution photographs of the moon taken from Earth, so the Earth facing hemisphere of the moon, projected those onto a spherical globe, and then he was able to photograph various features around the lunar limb as if from a bird's eye view or from a spacecraft side view. You do get some distortion effects and some focus differences and things like that. But this is one of the ways that the Mare Orientale, the features of Mare Orientale, were discovered by using this technique. Really a neat innovation that he did back in the day. Here's another one, The Photographic Moon Book by our friend Alan Chu again. This one's also full of detailed images of the moon. All the images are done with the Newtonian telescope view, so flipped 180 degrees. Lots of science content. And it's a free download at this link. So just head on over to Alan Chu's website, download the book. It's yours. A couple more downloads that are really great. We've got the Lunar Source Book, A User Guide to the Moon from 2014. This one focuses on the scientific results from the Apollo and some of the other USA and Russian exploration trips to the moon. Another free download from the Lunar Planetary Institute. And here's another one, Don Wilhelm's The Geological History of the Moon, comprehensive review of the science and lunar evolution based on both trips to the moon and also photogeologic observations. And it's another free download from Arizona State University Space Exploration Resources. Well, Don Wilhelms is back again, To a Rocky Moon, A Geologist's History of Lunar Exploration. This is how the geologist coached and trained the astronauts to do the exploration when they got to the moon. And so it deals with that as well as a number of the geological discoveries made during the Apollo missions. Another free download from the Lunar Planetary Institute. So those are the books. Let's move on to some of the apps. So the one that I have beside me at the telescope all the time, both for deep sky object, well, for the lunar observing, is the Lunar Map app, and it's also the Lunar Map HD. So the Lunar Map is free for Android, and the Lunar Map HD is a few dollars. It's just $2 or $3. There's also an app I haven't used called the Moon Atlas app for Apple, which looks pretty good as well. It seems to do much the same thing as this one does. So what you get is a full Earth-facing globe of the moon, or a detailed closed high-res map of the moon, with a real-time line drawn for where the terminator is now while you're using the app. There are options to flip the view to match your optics types. You can stick with binoculars, or you can flip it around for SCT, refractor, Newtonian. It has the ability to flip between multiple maps of the moon, and there are even a set of maps for the far side of the moon. The maps are highly zoomable, and the labels can be, even the finer, smaller features are labeled on this feature. And you can tap a label to summon Wikipedia information and things like that about it. This is great to have on a tablet, which is a little bigger screen near the eyepiece, near the telescope. One disadvantage is that you can't change the terminator to off the current date and time. So it's great for at the telescope, but it's not so great for, planning what you're going to see or reviewing what you saw, in terms of where the terminator is at that time. Now, a lot of us have used Sky Safari and Stellarium. So the Sky Safari Plus and Pro versions for both Android and iOS are great. The basic version of Sky Safari, as far as the moon map goes, is a bit less powerful, a bit less detailed. So what's great about Sky Safari is that you can view the moon at any time, or any date and time. It has flip buttons to match your optics. It has the ability to display field of view indicators or rings around the moon. And you can label the moon, but I find that the labeling in Sky Safari, the moon labeling, is a little bit too busy for my taste. Whereas the Lunar Map HD, it does a bit more smart labeling, where the bigger features have bigger labels, the smaller features labels don't appear until you zoom in, that kind of thing. The moon map itself is fairly limited resolution, and the terminator shading, I would say, is a bit so-so for Sky Safari, but it's great if that's what you have. I definitely recommend adding on the Lunar Map app if you want to get serious about looking at the moon. Now, Stellarium for desktop recently did a major upgrade. We're at after years of version 0 Stellarium, we're at version 1.xx now, and its moon map has improved. It still could be a little bit better, but it's improved. That's nice is that the Stellarium nomenclature can be displayed and searched for features as you could for Sky Safari. And what I did is I created bookmarks and observing lists that will work in Stellarium for the RASC programs. The binoculars, the telescope, the Explore the Universe, not the Isabel Williams, which we'll come back to in a little bit here. But I'll give you the link in a minute where you can find those bookmarks. So here's a screen cap of the tablet version of Sky Safari showing you the labeling, and the greenish bluish ring is the field of view of I guess that's about a 5mm eyepiece in my telescope. So let's talk about some online tools. So one of the neat ones that I discovered recently is the Moon Trek tool. Let's see if I can find this one here for you all. Here we go. I'll bring this over here. So Moon Trek is a way to explore the moon in a browser window. You can actually use it as a flat moon map, or you can go down here to the tool and choose 3D globe. And from here, you can rotate the moon around. So it's not great for giving you just the Earth's surface view of the moon, but you can really dive in and get more and more detail on the lunar features. It's even got subframes in here for some of the high-res regions around the Apollo landing sites and things like that. And you've got the ability to type in a lat long or a place name and fly to that location. So that's a cool tool. Another really great one, and there's the link to it, trek.nasa.gov/moon. Another really great tool that I love using is the Moon Phase and Libration Service, or tool, put out by NASA. So you can see it's here, gsfc.nasa.gov. It's kind of a funny URL, but if you search for Moon Phase and Libration, you should come up with it. They update this every year. So currently they've recently released the 2023 version. And what this does is it lets you open this link up, and it gives you the current moon at the current date and time in UT, Universal Time. So if you wanted to say, what is the moon going to look like this evening? Well, I've got it set to November 26th at 1 UT, which is about 9 p.m. or 8 p.m. this evening right now. So here's our crescent moon. And what this is great for is the ability to check the visibility of the lunar X phenomena. So if you hear about a lunar X, it's going to happen, but maybe the timing is not too clear to you. You can dial in the date, time, and you can dial in the different hours bracketing the lunar X predicted time and see when it does indeed look its most accurate. And what's neat is that you can actually click on any of these date, times, and hours that you dial in. So for example, if I were to go in here and put in, let's go back about 10 days. So we get the third quarter moon. So if you click on the image, it actually downloads a high-res version of that scene. So I'll bring that up for you to show that. That's a TIFF file. And you can see what it does is it actually adds labels to the features. And you can take this and zoom in on it. So that's kind of a neat thing as well. So you could set it up, ask for the moon appearance for this evening's observing session, grab this image and take it out with you on your tablet, or you can print it out, take it outside with you. So there are the links that you can find for those two versions. So the 2022 version and the 2023 version. There's even actually, if you scroll down on that page, there's even a set of images for flipped for Newtonian telescopes, so inverted. All right, so my adventures in moon gazing. So I didn't do everything in necessarily the logical order, but I did start way back when with RASC Explore the Universe program. So when I got became a RASC member again after a long gap away, and I began to volunteer at the David Dunlap Observatory sort of way back in the 2012 to 2015 era. I decided to do the Explore the Universe program. So it's a great program. It actually allows anyone to do the program and earn a certificate and a pin. I've got my pin handy here tonight, if you can see my Observe the Universe pin. So funny thing is I did this program a long time ago in this time frame. It's got 32 lunar basins in Maria and some major craters. You just need to look at 16 of them. In this case, you can actually earn the pin or certificate by observing about half the features in the program. I did it way back then, but I didn't actually submit it until a month or so ago. So that pin is nice and fresh. It's still shiny because I just got it. This is the telescope I was using at the time. It is a go-to telescope, but you're not supposed to use go-to for the system. So basically what I did is I did not have it tracking, and I just used the hand controller to slew around the moon. And what's neat is because it's an SCT telescope, a Schmidt-Cassegrain, I actually could put bino viewers on the back of it. So I was able to see the moon with both eyes and do the program that way. It's really fun. Here's just a little bit of the my log. So a sketch, one of the requirements is to sketch the motion of the moon over a couple of nights, consecutive nights. And so here's a Venus, Jupiter, Regulus, Venus, Jupiter, and here's the moon, the earlier evening and then a couple of nights later. Just an example of what you can do. Most of these programs do not require you to do sketches. I'm personally not much of a sketcher at the moon because I'm dealing with, reading glasses on and off, that kind of thing. But, you do some of them here and there, and it's kind of fun. Blake Nancaro reviewed my application, and he was really delighted by my sketches, which is kind of fun to hear. All right, next up was Explore the Moon Binoculars. Now, I actually started this one a little bit later. I was doing the Isabel Williams program first, but I decided I wanted something that I could do a little faster and with the binoculars, so I decided to try this one. It's called Explore the Moon Binoculars. Here's the website where RASC's various information packages and observing logs and all that you need to get started is located. It's for RASC members, so it's basically a beginner program for RASC members. It's great if you've got mobility issues and you need to be seated in a chaise or something like that, or if you don't have a telescope but you do have binoculars. And here's somebody that's gotten creative in the way they mounted their binoculars. It contains 40 lunar basins in Maria and some major craters. And again, you can observe them all and earn a certificate and a pin, which is shown here. So I recently finished this program and submitted that one. Now I did make Stellarium bookmarks for this program, and you can find them at the RASC Toronto Center website. We've actually made a page for the Stellarium observing list, and you'll see the Stellarium observing list that we made for the Messiers, the finest NGCs. I think the David Levy Deep Sky Gems are in there, as well as the lunar programs. And if you're using the Stellarium bookmarks, and if anybody's interested in seeing me do that, I can fire up Stellarium and show you how that would work a bit later. You also need to just remember to turn on the solar system nomenclature in Stellarium in order to use these bookmarks effectively. So the program uses something called the Q day system, where first quarter moon is considered day 0. And then the days prior to that, when the moon is a crescent, would be Q minus numbers, -1 day, -2 day, -3 day. And then as the moon is getting gibbous and waxing fuller, then it's the Q plus numbers. So as you move west, it's Q +1, +2, +3, +4. So basically between Q -6 and Q +6 gets you the full range of the lunar month observationally. I was really lucky. I had a full week of clear skies in May, around May 9th of 2022. And I had started when the moon was 1 day before first quarter. And I was able to pick up all of the Q values, or all the features in the eastern half of the moon on that first night. Now, you might say I cheated a little bit. I had this beautiful pair of Canon 10x42 image stabilized binoculars, which are amazing. If you're looking for binoculars or you're looking for something for the astronomer that has everything, I highly recommend. They're game changing. Those binoculars are amazing. And I use my Lunar Map HD app and just had that near me and sat in a chaise and had my logbook. I just went through the objects one by one, relatively easy. Now, interestingly enough, I was doing this in daylight because in May, the moon is nice and high in the sky towards sunset. And I found that I could see all the features while the sky was still blue and the moon was nice and high. And I got really good, clear views of the moon then. So obviously you don't need the image stabilized binoculars to do it. And here's just an example of a couple of my log pages from back then, May 7th, 2022. And you can see about every 5 or so minutes, I was able to move on to the next object, positively identify it, make a few remarks about what I was seeing. And one of the fun things that came up when Blake was reviewing my program on this one is I had written tiny Winals seen to upper right, and we didn't know what that was. And he said, "What's Winals?" And I said, "Oh, it's not Winals, it's tiny Winals." So it was special. But anyway, it worked out that it's the crater Weinecke. So I've gone back to my log later and written in crater Weinecke in my log now. So it will no longer be a mystery for posterity. But that was kind of fun. You will notice that I did not get the Altai scarp. I was not able to see it in this case. And as a matter of fact, I thought I was done the program and had it all ready to submit and realized, oh no, I never did get the Altai scarp. So I waited for the next available opportunity, and it took me several nights because the moon phase wasn't quite right to pick it up. And I finally got it earlier this month and got this one done and submitted. So some advice if you're doing this program, an erect image labeled moon chart is really helpful, either paper or app form. You do need to record your weather conditions, sky conditions, your opinion on seeing, the date and the time, so that the reviewers can see where in the sky the moon might have been when you got your observation. Good seeing is really important for moon observations when you're dealing with, finer features, smaller features. So that means steady air, and preferably if the moon is high in the sky, that both of those things help to give you a clear view of the moon. I would say that good seeing is even more important than a dark sky. So I would rather get that moon when it's high in the daytime than wait till it to be lower in a darker sky. I think the 10x42 binoculars, you know, they don't need to be image stabilized. They're a good size. I think if you got those or larger, that would be great. I don't know. I think I tried a pair of, you know, 10 by or 8 by 25s or 8 by 30. I don't think I was really able to see the features too well in those smaller sort of birding binoculars. Image stabilization or tripod, monopod, anything that can hold your binocular steady is a big help. So the January to May in evening, around first quarter, the moon is great. It's very, very high in the sky. The moon gets very low in the evening from June to December. So if you were trying to recreate what I was doing at this time of the year, you'd find the moon was much, much lower in the sky. I think maybe only 22 degrees as opposed to upwards of 70 degrees when I was doing it. Conversely, though, you could do the program in the morning. The moon is roughly in the same conditions that I was doing in the program at about 7 o'clock in the morning now. And the moon is nice and high. The sky is just starting to brighten up. And you could get the program completed by getting up a little early, right? Do it now. All right, moving on to the Explore the Moon telescope program. So I haven't done this one yet. I plan to do it soon. I actually have a 6-inch Maxitov. So I sold that blue Meade scope that I did the original Explore the Universe with, but I wanted to get back to bino viewing the moon, which I needed an instrument with a long focal range. So I was looking for an SCT scope or a Maxitov. So I ended up getting a 6-inch Maxitov telescope that I can use my bino viewers on. So I do plan to do the telescope program in the near future using that. So again, it's for RASC members only. No go-to allowed. It's a solo effort as all these are. So you just do it on each person. You know, a number of people in a family can do it, but they just need to make and log their own observations. 94 lunar features now instead of 40. Again, certificate and pin. Really, any size telescope will work on this program. The features are all designed to be big enough for any telescope. The optics do need to be pretty good though. Search for your features around at low power. So 50 power to 100x, 50 to 100x. From, as an example, a 14 millimeter Plossl in a 6-inch Dob gives you about 64 power. So that would work. And then observe the features probably at the higher end range, 100x or higher, and if conditions allow. Again, there are Stellarium bookmarks for this if anybody wants to use those. All right, now the big one is the Isabel Williams Lunar Observing Program. So this is the big one. This is the one I've been working on for quite some time, even long before I started the binoculars program. There are 268 required observations of various lunar features that are meant to be visible in an 80 millimeter telescope or larger. And then there are 178 challenging features for which you'll need a bigger boat. So 5-inch telescope or bigger than that. And then there are 19 optional observations, which are a mix of easy and hard. And these are things like craters named after Canadians or have Canadian connections, or features that are near the lunar limb, so libration challenges. And then there is even a few more aspects of this program, including the option to go beyond and observe 1,000 lunar features, which I haven't contemplated doing that one yet. As before, this time, very important that magnification, collimation, good collimation, and seeing are the key. Because remember that we're talking about hundreds, if not 1,000 features on the moon, all crammed into to an area of sky only 1/10 the size of the Andromeda galaxy. So imagine taking 1,000 Messier objects and cramming them all inside one Messier object. And that's sort of what you're dealing with when you're looking at the moon. You really need to magnify things up. So there's your link to the RASC resources on the Isabel Williams program, and there's the pin. So this was my pandemic lockdown project. I started it on my driveway on April 5th, 2020, so just weeks after the lockdown started. I'm nearly done 100% of it. So I've actually made a point of looking at both the required and the challenge objects, which takes you longer, but it's more, it's rewarding to do. My process was I got my collimation as good as I could on my telescope. I put my observing chair beside my eyepiece, turned off the tracking, of course, and I got the lunar map, HD map running, and set it to Newtonian mode so it matches what I'm seeing in the eyepiece. Sometimes I also check with Sky Safari or the Rookel or the Days books just because sometimes the names of features in the program may not be adopted or used by every resource that you have. So sometimes you have to open up a couple of different resources to really confirm what you're seeing. So for this one, you need excellent seeing and lots of power to see the challenge objects. I was routinely using either a 7mm or a 4.8mm Nagler in my scope, which gives me 225 or 330x, even more sometimes. I'd sometimes even power mate and double the power on these just to try to glimpse something tricky that I was trying to get a glimpse of. And again, obviously patience is a virtue here. So sometimes you need to wait for those moments of clarity when the air stabilizes, you can really get a glimpse of positive identification of a feature. So here's my setup. When I was on the driveway, I've got a 12.5-inch Obsession telescope. I've got a nice variable height observing chair, little red LED, logbook, set of eyepieces. There's my collimation, laser collimator tools in the background. And then, I've got, sometimes I tuck my log under this bag here to keep the dew off things. Normally I turn all the other lights off and things like that, but I wanted to get a nice picture to show what the setup looks like. So bear in mind that the most westerly features in this program will require you to be getting up really late or early in the morning. That's why it's maybe not as great a task to do in the summer months when you're waiting so late in the evening for the moon to rise and get high enough to look at. Remarking that November and December gibbous moons get pretty high in the sky, nice and clear and crisp views of those. So I've gotten every observation except for 3 things, my white whales, so to speak. So we'll come back to a couple of these in a bit. All right, so here's some of my favorite things that I've looked at during the course of my fun with the moon, looking at the moon. One of them is the crater Newcomb, which is up here, tucked above and between Serenitatis and Tranquillitatis, just in here. And what's neat is that it looks like a snowman. So in a Newtonian telescope, the view flips upside down. You've got Newcomb itself, which is 39 kilometers in diameter. And when combined with Newcomb J and Newcomb G, you've got Mr. Snowman, which I think would always enchants me and I think is fun. So if you're doing outreach and you want to give somebody a fun little thing to look at, that's a neat one. So this crater is named after Simon Newcomb, who was, obviously, we give the Simon Newcomb Award for writing after him, Canadian connection as well. Here's another one, the Reiner Gamma Swirl. And this one you can see in binoculars. During the course of the Moon Binoculars program, I noticed that I was able to see the Reiner Gamma Swirl through my binoculars. So it's here west of Kepler, near the edge of Oceanus Procellarum. And this is that neat stain, bright colored stain on the moon, very complex shape. It's possible that this is a case where ancient Mare basalts failed to darken because they were protected by an intense magnetic field. So protected by cosmic weathering by an intense magnetic field. So there is a magnetic anomaly buried underneath the crust of the moon here under the swirl. So this is a really fun feature. And one of the, I think it's one of the programs, at least, you're asked to sketch it, which is fun. Up here, so now we're getting into my white whale, some of my challenging features. Well, not white whales yet, but these are some of the more challenging aspects of the Isabel Williams Lunar Observing Program, was the rill that runs up the center of the Valles Alpes. So it's up here near the edge, near the Alpine Mountains, near the crater Plato at the edge of Mare Imbrium. And there's the valley. Valley's very easy to see. You can see that in binoculars. But getting a glimpse of this narrow rill, this crack that's running up the center of it, I found that really challenging. I needed really good seeing. It took me a number of different nights before I could confirm that I confidently saw it. And you might even find yourself seeing sections of it rather than full extent of it, which I think counts if you see much or most of it and not necessarily the entire thing. So this valley cuts through the northeastern rim of Mare Imbrium. It's 166 kilometers from Mare Imbrium to Mare Frigoris. And this is possibly a graben that has collapsed, or a crack that's opened up in the moon and collapsed the crust. It widens to about 10 kilometers wide in the center. And this is the inverted view in a Newtonian telescope. So you really need good seeing and a good collimation to see that little crack. Another one that I found challenging, maybe it was just me, but there's a little rill that runs between the craters Campanus and Mercator down here near Mare Nubium. And so here are the two craters that kind of look like a pair of spectacles or a pair of eyeglasses when you're looking at them. And it's a really cool part of the moon. You've got these great, neat curving rills that run through to the upper left here. But there's a little rill that's kind of subtle that winds its way between the two craters. And that's what gave me a tough time seeing it. So again, this is, you really want to pick the moon phase when you want to see this. So I probably was trying to see it on some nights when the phase wasn't quite right, but eventually I successfully got that. All right, I got two white whales that I'm going to share with you. And these are actually libration features that are tucked around the edge of the moon that only occasionally get kind of tilted in our direction. So obviously the moon wobbles and tilts as it orbits the Earth. And there are periods of time when various parts of the lunar limb are preferentially tipped or turned earthward. And so one of these is Mare Orientale that I mentioned earlier when I talked about Bill Hartmann. And that's one I haven't confidently seen yet. And so I'm waiting for a time when that region of the moon is librated towards us. And it turns out that you can use the Observer's Handbook, monthly pages, and look for these little dots that are marked around the edge of the moon. They are the points of the moon's limb that are preferentially tilted earthward. So you want to find a dot that's near the feature you're chasing, and you also want to find a time when that part of the moon is fully illuminated or is in full illumination. So when I looked this up, I found out that the next good opportunities for me to catch this white whale will be December 15th, 18th, when this is the arrangement as done by us, the program Starry Night. So in Starry Night, if you turn on the axes, you can see the axis of the moon, the equator, and the prime meridian, and you can tell that the equator of the moon is arcing a little bit, so the moon is tilted up, and you can see that the prime meridian is bent a little bit because the moon is tipped towards the east. So that brings this little dark strip of Mare Orientale into view on those nights. There is another opportunity in January if I miss this one, so fingers crossed. And here's another one. I don't know if I'm going to be able to get this one. This is the crater Plaskett. It's one of the Canadian connections. It's named after the Dominion Observatory director and past RASC president, John Plaskett. And it's a 109-kilometer wide crater that's technically beyond the lunar North Pole at 82.3 degrees north, 43.8 degrees east. And you really need the North Pole of the moon tilted earthward to have a chance of seeing it. I've tried a couple times so far, no luck yet, but it looks like using those resources, the next good libration will be the wee hours of July 5th, 2023, where you can see the equator is bent down here because the lunar pole is tipped towards the Earth. So fingers crossed that I get that one. So that's my adventure with moon gazing. Don't fret if the moon is bright. Set up your telescope, take a look, share it with friends and family, and have a good time with it. That's it.
Excellent. Thank you very much, Chris.
Thank you, Chris. That's so interesting. Timely talk with the Artemis and Orion launched recently, and Orion orbiting the moon. Congrats on your 2 RASC certificates. That's awesome.
Thank you.
Loved seeing your favorite features. Also, good luck, and hopefully it will be a clear night on July 5th, 2023 for one of your white whales there.
And don't forget, December 7th, the moon will occult Mars for us in the GTA.
Oh,
Fingers crossed for a clear night.
Fingers crossed, yeah, fingers crossed for that day too. So I actually did do the Explore the Moon certificate, and my favorite was actually the mountains, the Apennine Mountains by, I'm going to, mess this name up, but Mare Ibrium, absolutely gorgeous. And I do have a 5-inch Mac as well. And the views from that are just amazing.
There's a really
Also-
neat, yeah.
yeah. You can really see. You can really see the ridges, and you can see, you know, the features, and it's just spectacular when you look at it. It's awesome. I hope this your talk has inspired at least a few of us to go out and look at the moon and maybe get that certificate. I'll start us off with some questions. Folks, please post your questions on the chat. We'll ask them live. What are some of the craters that are named after Canadians?
Well, I have my Isabel Williams Observing Program booklet here. And if you turn to page 46, it's got the list of Canadian connections. Some of these I actually wrote up in Sky News several months ago, I think around the summertime, July, August issue. So we've got, let's see, we've got Oswald Avery, who was a physician born in Halifax. We've got Sir Frederick Banting, crater for him. We've got a crater for Carlisle Beals, who was a Dominion Astrophysical Observatory astronomer and RASC president. We have James Cook. We don't talk about too much about James Cook because we're not totally happy about him. Reginald Daly, who was a professor of geology. And we have Simon Newcomb, who I mentioned, and John Plaskett, who I mentioned as well. Unfortunately, the craters for Helen Hogg and some of our favorite, you know, Canadian astronomers are on the far side of the moon. Can't see them.
Well, maybe another crater forms at some point, and perhaps it gets named after.
You know what? The moon is loaded with unnamed features, and I don't see why we can't start using a few.
Yeah, absolutely.
Yeah.
Now, so one of the other questions comes from a member here. I think it's Kirby. Do they think that the Messier and Messier A were caused by the same skipping asteroid impact?
I can't remember if I read up on that. I honestly can't remember at the top of my head if they think it is or if it's a coincidence. Let's go back and look at that slide. Okay. Yeah, go back over here. Here we go.
I think I might have answered my own question. I was looking it up a couple minutes ago, and what I read is they think the one on the right was the first impact, and then it skipped and created the one on the left, and then all the ejecta flew out to the left. That's what one book says anyway.
Yeah, I mean, it could be a skipping stone sort of a thing. Yeah, you know, you can't see a ray between them. There's no evidence. It doesn't seem there's evidence of a ray between them. In fact, there's almost an argument that there's a ray system going north-south on the right hand. So perhaps it was two independent impacts. That's why we need to go there.
Yeah, no,
one of the many reasons.
So Chris, you had a comment here. It says Charles Wood has a 2-page column about the moon in every second issue of Sky and Telescope for the last many years. Very scholarly and interesting.
He's a wonderful writer, and I really found the book a page turner. I'm keen to read it again. It's not a lot, you know. Here's the book. If your center has a library, there's the book. Then chances are they have a copy of this. It's a great one.
Yeah, no, for sure. Another question then, I was watching the Apple show For All Mankind. I'm not sure if anybody's seen that, watched that. I'm actually rewatching the whole series. And it's all about finding water on the moon and, you know, how if history was reversed and the Russians got to the moon before the Americans did, what would that storyline look like? So curious, any thoughts about, you know, well, let's put it this way, the water, from a water perspective, we have found, or we think we've found potentially some trapped water on the moon. Mm-hmm. Where, I can't remember where it was located or where we think it might be. Any comments on that, Chris?
Yeah, I believe Artemis has about 14 or so southern polar craters in mind as potential landing sites. Wouldn't it be interesting if we end up with, you know, the Americans in the South Pole and the other folks in the North Pole, and got this, yeah, hemisphere thing going on? That I could see that happening.
Yeah, absolutely. Question from I'm sorry, Kitsa, I think it is. What is the average amount of time it takes to complete the Explore the Moon telescope certificate?
Well, I haven't done it, so I can't answer that necessarily. If you're familiar with the moon, so, you know, in full disclosure, when I did the binoculars program, I had already done much of the Isabel Williams. So I didn't have any trouble finding and identifying the binocular features. If I was starting from the absolute beginning, then it wouldn't take me just 5 minutes probably to log each program. So I think it's probably designed to be done, you know, it depends on the weather too. If you were to have a beautiful, you know, 1 or 2 weeks of clear skies, you could probably get the bulk of it done, you know, in 1 lunar cycle, but probably 1 or 2 lunar cycles, you could certainly get it done. If you wanted to give it a go. I'll let you know though.
Yeah, the Explore the Moon telescope certificate, I actually did do them. The year I did them, I think it was just around the pandemic time or the start of pandemic, that summer. Unfortunately, the weather didn't cooperate.
Yeah.
And it was, to your point, a couple of months to get, you know, when you kind of first quarter onward, it was okay. But the most challenging was when it was, you know, just coming off the new moon, crescent, right? The first couple of days, and then the last couple of days before going into the new moon phase. So that's where I found it very challenging.
So if you go into Stellarium and play around with the, you know, the Western horizon, or especially the Western evening horizon, you know, you can find times of the year when the ecliptic is more vertical and the moon's orbit is more vertical. And those would be ideal times to get that young moon while it's higher in the sky. So you can get strategic about this and do that. But there are always a couple of features that you missed that end up keeping you delayed. It's not as bad as the Messiers or the other programs though, where you got to wait 6 months and get up before dawn to get that object you missed. Yeah.
Yeah, absolutely. If it sounds like, Alan, there are no more questions in the chat. You're muted, Alan.
Thank you. Okay, excellent. I just have a couple of things to mention before we close off. First off, thank you very much, Chris. That was excellent. I'm going to have to go through the recording and have a notebook in front of me where I can take notes, because I was busy watching for people to come in, so I couldn't write any of this down. What I may do is capture all the links that you have put and dump them out in an email to the people that were on the call or our membership. I'll be nice.
Great.
Our next 2 meetings will be potpourri meetings because of the holiday season. We don't have another speakers night in December. And the next meeting on December 9th will be a Zoom meeting again. And the following meeting on January 13th may be Zoom, or it may be that we'll be back at UTM. We'll announce that closer to the date. I want to remind everyone to get their submissions in for the 2022 astrophotography contest. That closes December 20th. And you can find details about submission and everything in the latest Messenger newsletter, which is available on our website. And just a couple of other things from that latest Messenger. You really should read the latest Messenger. Kirby Alguire, who's another counselor, has a really great write-up about the dark sky observing session that he organized in late October for that 16 members attended. It was in Vineland, and I meant to go, but I had a small injury that I was dealing with. Next one, Kirby. And there are also a whole bunch of really nice shots of the lunar eclipse that was just a few weeks ago. So On that note, I'd like to thank everyone for attending and thank Chris again for that excellent talk. And we will see you all. Yes, agreed. Clap, clap. We'll see you all again on December 9th. Thanks very much. Bye, everyone.
Bye, thank you.
Bye.
Thanks, everybody.
Thank you.